Okay. Hello guys. So let's begin with the today problem of the day. Minimum number of operations to make array empty. So let's first try to understand the problem statement. So in this problem, we have given a zero index array that consisting of positive integers, and we are allowed to perform two types of operation. First operations is that uh, if two elements are equal, then we are allowed to delete this both the elements. In the second operation, if three elements are equal, then we are allowed to delete all these three elements in one operation. And we need to find out the minimum number of operations required to make the array empty. And if it is not possible, then directly return -1. Okay. And I think the problem, the constant of the problem is 10 to the power 5. It means that we need to solve this problem in big O of n, and it will also pass if we solve it in n log n. Okay, so let's see. So so for this problem, we need to first count the frequency of each element, because we are allowed here to delete the numbers if two numbers are same, or whether the three numbers are same in the second operation. Let's try to understand more about the problem statement by the example 1. So if we count the frequency for each of the element in the example 1, so the frequency count for element 2 is 4, for element 3 is 3, and for element 4 is 2. So 4. So I think here the minimum number of operations so that we can delete all the four element is 2 and 2. And yeah, so 2 and 2, you can delete 2 at the first time and again delete 2 in the next time, so two operations are required. For the 3, the count of 3 is frequency count of 3 is 3. So if we apply operation 2, then we can delete all the three elements simultaneously, so one operation is sufficient. And for 4, two elements are there, so one operation of first type is sufficient. So total 4 operation. Okay. So I think if we see how this code is working for frequency count of 1, 2, 3, 4, 5, 6, then we will get some clear idea about it. So let's see. For 1, is it possible? No, it's not possible, because no any type of operation can delete this element if the frequency count of any element is 1. So in this situation, we need to directly return -1. For frequency count 2, one operation is sufficient. For frequency count 3, one operation is sufficient, second type of operation. For frequency count 4, two operations are required, both of are of first type. For frequency count 5, one of the second type and other two operations are required, one from the first type and one from the second type. And for 6, two operations are required, both are from the second type. So okay, so if we now analyze and observe our results, we can say that for 3, one operation is sufficient. For 4, two operations are required. For 5, again two operations are required. And for 6, again two operations are required. So we need to find the minimum. So first we will try to find out the number of operations can be applied by using type 2, second type of operations. So that's why first we try to divide any number by 3, and whatever the question, that will definitely add into our answer. Then we will find the remainder. In the case of 4, the remainder we will get is 1. So if you see, that's why here answer is 1 plus 1, because 4 divided by 3 we are getting 1, and again 1, because we are here not applying second type of operation. For 4 we are applying both the first type of operations. That's why 1 plus 1, 2 operations total required. For 5, again 2 is the remainder. So directly we are applying here first type of operation, and we are getting whatever the question plus 1. And for 6, the remainder is 0. So directly whatever the question is the answer. Means yes. So I think the problem statement and the approach is clear. So let's begin with the implementation of the coding part. So unordered map I am taking. So this is the data structure that I am using to first count the frequency of each element. Okay. So frequency nums I plus plus. Okay. So here we get our the frequency count of each and every element. We need an answer variable. So let's say int answer equals to 0, and then iterate through this array, sorry, through this map, and just check if it dot second equals to 1. It means that we need to directly return -1. Else, in all the other case, by using those two operations, it is possible to delete those elements. So I will add those into my answer. So it dot second divided by 3 plus it dot second modulo 3 is not equals to 0. It means that it has some remainder, then this function will return 1, and 1 will be added, one extra 1 will be added to our answer, and at last just directly return the answer. That's all. So let's run it. Okay, so the two given sample test cases is giving correct answer. Let's submit it. Okay, so it gets accepted. I think the runtime is little more, but okay. This is the most optimal and efficient approach for this problem. Thank you.